Special compared to my skills because I'm here to present, so coffee would be extra. I was my own driver, now I present, so coffee would be like super. I think I will keep it like that because actually it's my shirt which does the noise. Probably it's not an appropriate shirt. I need to get that one.
ESD shirt.
Sorry?
ESD shirt.
Yeah, tomorrow I will do a t-shirt because I wanted to be nice in the morning presentation because that was supposed to be a business kind of stuff, so I did my best to show up in a shirt actually. Alright, I think we are complete. Welcome. Oh, two more. Good. One more. No. Okay. Welcome everyone. I'm gonna get started anyway. My name is Yacin. I use only my first name, already creates a lot of fun. So just before this session, we have a booth somewhere in the middle, and my colleagues were making fun that who can spell better my name. Obviously, most of them failed, so that's good. So my name is Yacin. I'm a storage infrastructure architect for NetApp. I work for NetApp for 7 years now. I do nothing else than technical stuff, so you can be safe to ask me about any prices because I have no idea, okay? Although, obviously I have some understanding what's more expensive to other stuff, so I will refer to things that they are cheap and they are expensive, so they are like kind of compared to each other, okay? So what I was planning to do is VMware environments. I'm not strict to VMware, okay? The reason I flew with VMware because still, if you look at architecture, so when maybe you see it from my gray hair, but when I started infrastructure, there were no virtualization, so we did everything on physical. But for at least 10 years now, I'm dealing with virtualization. And if you look at the virtualization market space, it's over 90% virtualized. And the virtualization part is majority is VMware. So obviously, majority of, there are a lot of things in here which are VMware specific, but a lot of the stuff can be done with anything. If you have KVM-based virtualization, or you are using Zen or maybe Microsoft Hyper-V, then these solutions, most of them are going to run just fine, okay? Specifically to VMware, we started to work together in 2002. So we did actually support the first GSX. Anyone remembers GSX in the beginning of the 2000s? Yep, that was cool. That was the original idea actually. And then obviously the first versions of ESX came out. We started to work closely with VMware. In that time, they were not owned yet by EMC, so obviously we were a little bit disappointed when EMC bought VMware. But whatever, we continued to work together. A couple of things. So basically, we started to work on the integrations, but there was a lot of side effects. So for example, in 2007, we figured out that we could do primary storage deduplication, and we didn't plan that, hey, we are going to do deduplication for VMware environments. It was completely adverse. It's completely opposite. We made virtualization, we made deduplication, and there was a smart guy who figured out that, hey, it works extremely well in VMware environments. But if you look at the roadmap here from 2002 to basically these days, we currently have over 50,000 customers who are joint VMware NetApp customers. So these numbers are actually coming from our auto support. So basically, there are at least 50,000 customers who run a NetApp storage, and they have provisioned something for VMware. So that's where the matrix is roughly coming. So it's not marketing and Gartner and blah, stuff like that. Okay, generally speaking, we managed to build a super big portfolio by 2018. So we have like three different storage platforms, a lot of cloud solutions, and so on and so on. We have three different storage platforms, and in this presentation I will speak about that, how they relate to VMware or basically virtualized architecture. How you can use them, what's cheap, what's expensive, how they work together, and so on and so on. So I will start from cheap and going to a little more, let's say, difficult or not so affordable solutions, and you will see by the end. So the first is E-Series. So if you never met E-Series or you don't know what E-Series is basically a super simple, basic block-based storage. It's easy like a direct attached storage. It's basically fast, simple, and reliable. We sell it super cheap, really. And in a lot of cases, E-Series comes up in VMware environments. And although it's not our main focus to sell, but especially in Eastern Europe and Southeast Europe, there are a lot of customers who are using E-Series as a direct attached storage in VMware environments. So what's the reason for that? If you have a small environment, so you are planning something like either primary site or a DR site, where you are not planning more than 2, maybe 3 physical servers with a bunch of VMs on top of them, there are two possible ways you can do. You can order all of the servers with internal drive, and then you try to figure out what to do on top of it. Or you can do this class on the server side, and you can use something like a central storage between them. Obviously, for VMware high availability, there is something shared needs to be done between the servers. So what we typically propose, and what typically our partners are doing in this extremely small environments, is that they use an E-Series storage array. We support it to be directly connected to the physical host. So you don't need to purchase fiber channel switches or 10G switches. It's basically a 2-controller appliance, so you still reach high availability, directly connecting, and up to 6 servers you can basically go fine without the switched solution. So in small environments, 2, 3, I typically propose it 2, 3 physical servers, but you can go as big as 6 physical servers. To give you a feeling about how difficult the system is, once I had a partner who asked me to do an installation workshop for their partners, that how they can install E-Series, and they asked me to do a half-day course on that. And I told them, the whole thing installation is 30 minutes, so if you ask me how to do a half-day course on this thing, that would be extremely hard. So it's really, basically, it's a set and forget thing. After booting of the system, you basically, 25 minutes later, you have a system completely up and running, and that's it. And basically, you can set and forget completely. So this is about E-Series. I didn't see him from the floor, so it was like a ghost coming in. So some of you may know the system. Basically, IBM was reselling the E-Series product line as the S3 for 5,000 systems. This is exactly the same software. Obviously, over the years we did improvements and things like that. But at the end of the day, we go for the simplicity and the reliability. There's some other post. I think I should go to the other side. I keep it. Okay, so the next thing, and obviously the bigger part of what I want to talk about today is ONTAP. So ONTAP is our flagship product. We started with ONTAP in '92, and this is our main product. So in ONTAP, we have a massive plugin framework with VMware. So we do, and VMware, I refer VMware here like a company. So we not only vSphere as a data center, but obviously end user computing, and even up in the cloud. So we work together with VMware in their Amazon deployment, so they can use some of our solutions, and we can build joint environments. So what is ONTAP? ONTAP is a scale-out multi-tenant unified storage array. So this is basically our kind of a Swiss Army knife. This is in most of the cases what we propose to customers to run a generic data center enterprise applications. This is the technology what we use today. Currently, you can pick it up in a hybrid format or in an all-flash format. We start small, medium, large, and basically as it scales out, you can mix and match different type of nodes, different size of nodes, and different different time scale nodes. So for example, if you start out in 2014 with a pair of nodes, then in 2017 you can extend it with other type of nodes. What we build ONTAP for is reliability and to have a non-disruptive operation. So obviously VMware, or generically speaking, virtual environment, they bring a lot of the non-disruptive operate features, because they add you a vMotion or a storage vMotion. Other virtualization solutions call them live migration type of features. So these features help you a lot to migrate data and migrate applications between different storage levels or different storage layers or different storage technology, obviously. What we build ONTAP for is to do it on the storage level, obviously. So either with an automation or even as disrupt, or in a lot of cases we have customers who are running multiple type of virtualized solutions, so helping them, to go between different layers of storage technology or different tiers or different technology solutions. All right, so to use some of the Gartner stuff. So sometimes Gartner do something useful, and they do a metric that enterprise capability, so how many of the storage can be used for enterprise capabilities, and ONTAP itself, basically the software, is in every single category is above 4 out of 5, which is actually pretty good. So either if you are looking at database environments or consolidation or server virtualization, ONTAP is extremely reliable, and it's a good thing. So even if you think ONTAP is basically 25, 27 years with us, some would think that okay, it's the way you say it, it's a long thing on the tooth. Obviously, we are keeping rewrite it. Basically, from historical point of view, we did a complete rewrite somewhere around 2011, and majority of the improvements today go into the performance side, especially in the all-flash form, the capacity usability side, especially in the all-flash, and the interoperability with, especially with the hyperscale providers. Speaking of all-flash, in ONTAP, as I already mentioned, in 2007, we started to work with deduplication, and deduplication in VMware environment are extremely important, because VMware environments are the obvious where you can reach a lot of efficiencies. We actually did this in VMware in basically hybrid storage environments as well. So even if you are running like disk-based solutions with some amount of SSDs, it can work out fine. But obviously these are more important if the storage solution is mainly running SSDs. A couple of years ago, I did a demo exactly in the same room. I created a VMware data store. I fired up a couple of VMs and demonstrating the application feature. So obviously that was based on the code we did in 2007. Since 2007, we worked a lot on it, because the software was good enough for a hybrid environment. It's not really good anymore in all-flash. So we added a couple of new things, and generally speaking, in VMware environment, we can achieve easily a 3-to-1, maybe 4 or 5-to-1 level of basically storage saving, only if I'm looking at dedupe and compression. If you do data protection with clones and different snapshot technologies, this level can go up much to a higher level. Not specifically to VMware, but a couple of years ago we came out with the quality of service feature. And the quality of service feature become extremely important in VMware environment. And the beginning was not so easy. To tell you the truth, it was because in a VMware environment, it's not really easy to isolate VMware VMs from each other. And this can be exactly the same thing in a Hyper-V environment or in a KVM environment if you are using block-based storage. So if you look at the architecture, basically the way it looked like is that from the storage perspective, you basically deploy a data store. And on top of the data store, VMware or the virtualization solution is going to create a file system. And on top of the file system is running different virtual machines, right? So in the different virtual machines together create some type of performance characteristics. And if you follow this path, although you could do quality of service on a granular level, you cannot really do it on the VMware side because basically the 5, 10, or 25, or 100 VM what you put on a single data store, they will work together to create an application profile or a performance profile. 5 years ago, when we came out with the quality of service feature, obviously we started to tell to customers that, you know, if you deploy an NFS data store instead of a block one, then you basically from the storage side you can see the individual VMs as individual files, so you can apply quality of service policies. Originally, this technology was only used for limitation. So you said that, okay, I'm creating virtual machines on my data store, and I apply performance policies for every single virtual machine. So I'm telling my, let's say, Oracle VM that the Oracle VM can do 1,000 IOPS, but my junior DBA created test VM can only do 200 IOPS or something like that. So it was already possible 5 years ago to do it on NFS data store, but basically we obviously extended the capabilities of the quality of service, not only limiting, but also guaranteeing performance on a per virtual machine level. So basically today, in 2018, what you can do is that you can create VMs and you can basically guarantee performance levels and maximizing performance per VM in a VMware environment, which can be extremely useful. Still, personally, I believe that the data protection capabilities are the most important in an on-tap environment, and that's basically the NetApp DNA to create integrated data protection on a VM level on the storage system and being able to work with it. And basically for this, we treat different applications and different environments in a different way, obviously. So starting from importance point of view, the first thing we created in 2003 was what we call Metro Cluster. So Metro Cluster is a 2 data center active solution, and basically we started to work around 2006, 2007 with VMware to create Metro Cluster together with VMware to be able to extend a single data center into 2 sites and handle 2 sites together as a stretch cluster. The original solution was nothing else than basically a white paper. So we sat together with VMware, we produced the white paper that this is the way you need to build the infrastructure, and if you do this, you will get a stretched VMware H8 cluster between 2 locations, and you can seamlessly fail over and fail back between the 2 sites. So obviously VMware wanted to go beyond that, and they basically released this as an option in the hardware compatibility list. So now you can go directly to the VMware side and search for storage Metro Cluster and look for the vendors who are supporting this. So basically we propose this into mission critical environments. The extremely important addition by VMware during the years is that now they are supporting fault tolerance as well. So that means that if you build a 2-site stretch cluster like this, then you can achieve three levels of data protection. Level 1 for mission critical environments that you can use VMware fault tolerance. So even in an event of a complete site failure, your mission critical application is not going to have a single second of outage, nothing. For level 2, you can use VMware HA, standard high availability, just like in a single data center. So any physical host failure basically will do restarting of the VMs one by one, and in case of a full site failure, basically the VMs are going to restart on the secondary site. And the third option is obviously no protection, so you don't have to use VMware AJ or fault tolerance for every single machine. You can use them with an asynchronous replication and using the site recovery manager. So obviously we provide an adapter to a site recovery manager, so you can, if you don't want to build for metro cluster or if you have longer distances, then you can work together with SRM and create an automated way of switching over and switching back between the sites. And the last option in the workflow is basically creating or protecting basically the integrated data protection part. So originally what we did before releasing any product in the middle of the 2000s is that we started to create snapshots on the data store level. And without any application integrations, it's still good enough, because what you are doing is that basically you are creating crash consistent backups of the VMs. So if there's any failure, you can just go back in time and you can start the VMs and they will start if it would be like a standard crash. But we started to work and implement VM level applications, and obviously later we started to work with third parties, and we became the first storage vendor who worked with Veeam, and they created their suite for us. Okay. So originally we called the storage this storage integration as a step manager for VMware environments. A couple of years ago, we completely redesigned and rewrite the whole thing, and we are calling it Virtual Storage Console. So the Virtual Storage Console is doing three very important things. One of them is monitoring, so monitoring the whole infrastructure, not only the storage part, the server part as well. It's helping you provisioning storage into your VMs, and the third thing is doing the data protection. So you can use our software or any third party like Veeam or Commvault for the data protection piece. So this is an example of a performance dashboard out of the monitoring part. You basically see what you see is that you see a capacity overview and the performance overview, and then you can go into data store views and looking at the specific virtual machines, how much performance and how much capacity they are basically consuming. So this can be especially entering fiber channel NFS environments. This can go and drill down into the single VM level as well. On the monitoring part, what is more important than just looking at capacity consumption and performance consumption is basically to look through the architecture and making sure that you are following the recommended practices what we put together with VMware. Because unfortunately or fortunately, there are way too many things you can set on a storage array or what you can set on ESX hosts or in the vSphere level. So basically what the agent is doing, it's monitoring the environment and basically compares the configuration settings together what we set in the recommended practices. So it basically has two outcomes. One of them, the document for VMware recommended practices on top used to be like a 300-page document which was going through and try to set the values one by one. Today, it's basically you look for the monitoring part you basically check the systems, and basically you can verify if they are following the recommended practices or not. And if they are not, you basically just right-click and set the proper values. And also the other thing is that when you provision storage using the VMware piece, the plugin piece, that basically it will create the data stores and the VM case for the VMs that it guarantees that it will follow the recommended practice. So that's a good thing. There's also a big change. So I already mentioned with the quality of service that on top of traditional block-based data stores with VMFS file systems, that it's really, really hard to monitor the individual VM performance, and it's really hard to enforce the individual performance. So obviously we were the biggest advocate for virtual volumes. Any of you using virtual volumes in production? Still not. That's interesting. So the technology is interesting. When I joined NetApp in 2011, VMware was our own roadmap. And we've been working together till vSphere 6.0. And 6.0, it was basically released for general availability. Obviously, before GA, VMware released it under tech preview, so customers could download and start to use it. But currently we are 6.5, and a couple of weeks ago, VMware already released 6.7, and still VMware is not having a mass deployment. So the benefit of VMware VMware is that if you look at from the storage perspective, then every single virtual machine and every single application has dedicated storage resources. So obviously in an environment where you want to monitor the performance part on the VM level and the application level with virtual volumes, you can do it from the storage part because you have a clear understanding that what VM is using what. The bigger value though is that with the virtual volumes capability, you can actually access, you can actually use policy-based management. So instead of going through in an environment and defining policies for every single VM manually, you can set up policy levels, and when you provision a new virtual machine, you can just put it in a specific level, and it will inherit the performance capabilities, the type of storage is using, the deduplication settings, and so on. So basically the way it's implemented is that the storage system has a storage capability profile. The storage capability profile is inherited in the VMware environments, and using these profile elements, you put together a storage policy which the VMware virtual machine can adopt. And basically, if you are using this, then when you are creating a profile, you can manually set up a minimum, maximum IOPS per specific virtual machine. Going back to the data protection part, in the data protection part, we basically detached the plugin from the monitoring part. So originally, a couple of years ago, we had a mass piece together which did everything. 2 years ago, we made a decision to split the monitoring and provisioning part from the data protection part. And the reason mainly we did this is to simplify the operations and simplify the way you use it. And also, especially in big environments, the roles are a little bit different. So in typically large environments, there's a backup team, there's the storage team, and there's the virtualization team. And for these, we need to have different roles. So basically, the Snap Center if you are an existing customer having all the licenses, you just continue to use exactly the same thing because the licenses don't change. So today we call it Snap Center. The Snap Center is a little bit different than Snap Manager used to be, but it's basically controlled under exactly the same license. So what we do is that Snap Center, we integrated the Snap managers into a single Snap Center interface. So it used to be one by one per application, which now is centralized into the Snap Center interface. And the Snap Center is having a plugin what you deploy on your VMware environment. And at the end of the day, it does exactly the same job. So basically what it's doing application level and VM level integrated data protection. So basically application level backups and restores. I prepared a short demo for it, and I was thinking which part to demonstrate, and I figured out that probably the restore part would be more interesting. So basically here you will see that what is the how it look like restoring the VM. So basically I'm selecting the VM, and from the VM I'm going to the Snap Center GUI, and I'm clicking on restore. I need to select the specific snapshot I created. I have a filter so I can set up different time frames. But what's interesting and used to not be there is that I can select between primary, secondary, or both. So basically, if you remember the flow, you can do snapshots on a primary, and then you can use different replication technologies to protect the snapshot from the primary system to a secondary. The secondary can be on-prem, on a different site, or in the cloud. And basically, the Snap Center is able to fetch the snapshots. They are either on the primary, on the secondary, or even up in the cloud. So basically, once you selected this one, you set that which specific snapshot from the snapshot policy you want to restore, and then you simply restore that specific snapshot. So the interesting part is that this capability is not limited to Snap Center. So basically, so I will stop the demo because this was the interesting part. From timing perspective, you can imagine you can expect restoring a VM somewhere between a couple of seconds and a few minutes. So typically 1 or 2 minutes if the snapshot is local. The interesting thing starts when the snapshot is remote. So what happens when the snapshot is remote is that we have a capability which is called single file restore on demand. And basically what it's doing is that it will create an empty LUN on the primary array, and will tell the VM that, hey, your restore is done. So the VM can start the LUN or the VM decay, and basically on the fly it will start to read the data from the remote side. So basically what it means is that you can restore and you can start up the VM immediately after the backup, so after in a couple of minutes, but it will use the data on demand from the remote side, which means that basically the access will be actually slower. So this capability is available both from Snap Center, or if you are using Veeam and NetApp together, or Commvault and NetApp together, you can also use this capability with them. So let's go back here. So as I went through the ONTAP part, in ONTAP, the majority what we are doing is monitoring, provisioning, but the real sense of using ONTAP in an enterprise environment is the VM level data protection what we are doing. It can be either metro cluster environment or an asynchronous environment. The next thing I will look at is the next generation simplification. So we work with a lot of customers who want to get to the next level. In a lot of cases, customers are happy to do layered administration, where they have specific teams to do storage, virtual machine management, and application level management. But in a lot of cases, they don't want to follow this way. And that's why, if you look at the market, converged and especially hyper-converged environments are getting extremely popular. So what you see on the picture is that basically the daily task of an average storage vendor. It has 40 plus different tasks what you need to do every single day if you are dealing with storage. And basically, the next generation simplification should be from a VM side or from an application side, is just to be able to create a data store, set the name, how big is it, and how fast is it. So that should be the manual work part. So what we did is that we built the Solidify platform for almost 100% automation of these environments. So basically, instead of spending the time with storage provisioning and management and monitoring and basically babysitting of the storage environment, the storage part does it fully automated way. The management part goes almost only through the API, so we actually provide the GUI, but we don't like you to use that specific GUI, okay? So obviously we encourage the customers to use the automation, especially in VMware environment. And we, outside of the plugins, we support obviously the SDK. So I personally didn't born that I could automate my stuff. So back in the days when I was doing daily management, the way I did it step by step. So basically I started to write scripts in Bash, and then I switched to Python, sometimes Perl, but Perl looks extremely weird. But for example, a lot of customers expect and likes PowerShell. So basically the way we work with the automation piece is that in the GUI, when you want to start with the automation, you can put together a specific task, and we will generate a specific code task that what you would be able to copy paste into your code and start with the automation. I will have a session tomorrow only on the hyperconverged stuff. So if you are interested, it's 10 in the morning. It's supposed to be high level, but probably I will get technical. That's what I expect from myself. Okay. And the last piece is the complete opposite from what I've been speaking till now. So till now, I've been speaking about when NetApp as a storage system runs VMware applications, stores the data for VMware applications. And originally, our idea was to be a software company, to sell software to customers, but customers didn't want to buy software in the 90s, they wanted to buy storage appliances. For the last couple of years, the customers want to buy actually software, and they don't want to buy hardware appliances from us anymore. So we had to release a software-defined or software-only version of our products. So we call this product today VNAS. The reason we call it VNAS because we used to have different names for this product, but we started to work together with VMware, so customers can use this product on top of vSAN. So that's why the VNAS name is coming. Okay, so basically, thank you. So basically, what's happening is that you have an environment where maybe you have an external SAN, or maybe you may not have an external SAN, and you can use ONTAP inside the VM to do file services. It's typically used for file services. It has a lot of different use cases, which I don't think they are valid. But today, it's reasonable to use ONTAP for file services instead of using Microsoft virtual machines because of simply scaling and manageability and performance consideration. So basically, it starts from a single VM, so you can use a single VM without any high availability. It basically licensed per terabytes, but basically what you get is you get a single VM, runs ONTAP software, having exactly the same capabilities like a physical one. So you can set up a complete file sharing environment, you can do replication, integrated data protection for the shares, and so on and so on. So you basically get exactly the same features. It can go high available. So basically, if you want to have a reliable file sharing solution, it can be high available with 2 nodes, or it can scale out to 4 nodes. So with the 4-node option, you can basically go without any variation because the storage will take care of the high available part. There are, for this, going scale out beyond the standard file services, there's an additional use case. So there are a lot of environments where you use standard servers, you run a basic KVM-based virtualization, and on top of the virtualization, you use the virtual storage appliance. So you can basically build a 4-node storage appliance using third-party Firebox hardware, Linux-based KVM virtualization, and having the storage appliances on top of that. Lately, we actually built a Metro cluster version. So up to 10 kilometers, you can actually build a Metro cluster using the software-defined version of ONTAP and achieving 10 kilometers distance active data center, either using VMware or KVM. So this is currently where we are. Obviously, we can do the same exact thing in the public cloud. So for example, if you use Amazon Web Services or in the near future in a Microsoft, then basically you can achieve the Metro cluster capability in the private cloud as well. So you can use a software-only Metro cluster on-prem, but you replicate into a public cloud-based Metro cluster in the cloud. So that's how roughly the future for ONTAP look like. That's what I planned for this session. I hope it was somewhat useful. If you have any question, I think they will kill me shortly. So if you have any question, you can find me. Our booth is somewhere in the middle. It has big logical NetApp design on it. You can find me there today. Tomorrow I'm absolutely here till the end of the show. So you can come to me and ask any question. Hopefully I will find an answer for you. Thank you so much for coming.
Thank you.